So this is distance vector routing using the Bellman-Ford algorithm. The graph will be given with the costs and all these things. If you hear Bellman-Ford or distance vector routing, first thing is you have to calculate the number of iterations. So number of iterations. So number of iterations will be how many nodes are there? 1, 2, 3, 4, 5, 6, 7. So number of vertices is equals to 7, and your number of iterations will be n minus 1, which is 7 minus 1 is equals to 6. First step is to calculate the number of iterations, which is number of vertices minus 1, which is 6. Now what you have to do is you have to construct a table in which you have iterations. Now they would be asking from A to all possible. That would have been the question. A to all possible is the question. So I'm starting with A, right? So iterations and all other nodes you write A, B, C, D, E, F, G. Bangalore got its first train in Begur. Lot of chaos. Okay, number of iterations is 6. So write it down from 0, 1, 2, 3, 4, 5, 6. And for A, initially what it will be, from A you are starting, no? Which is your source. So it will be 0 and all others will be infinity. So now initially 0, infinity, 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 and the number of iterations is 6. So write it down. So now from A to A it is going to be 0. From A to B, how much? 2. A to C is not there, D 3, and E, F, G, all these will be infinity because it is not there. So now among all these, which so this will always be 0, so write it down as 0 always. Among these, which one I should be choosing? I should be choosing 2. So I am going to tick A and B here as well as here. So now using only these two, I should keep checking. So next iteration, so here 2 is B is done, so write off 2 for all the B, and now I should start checking for all these things. So using only these two vertices, can I access C? Yes, there is only one possible way, which is 5 plus 2, that is 7. So write down 7. Can I access D using these two? Yes, there is only one possible way, but that is 3. So write down 3 yourself. Now can I access E using these two? Yes, that is 4 plus 2, 6. No other way is there, only this is the 4, 5, 6. And F and G I can't, so it will be infinity and infinity. So now among all these, which one should I choose? I'll be choosing 3. So now I'm going to tick D here also, and all the D's I'll fill it up with 3. So now for the remaining I will check. So using these A, B, D, can I access C? Yes, there is only one possible way, that is this. Only one possible way, which is 5 plus 2, 7. So it will remain the same. Next, can I access E? Yes, there are two possible ways. One way is from like this. So 4 plus 2 is 6. Another way is like this. 5 plus 3 is 8. So 8 and 6, which one will I consider? I would consider 6. So it will remain the same. If at all this were to be 1, then I would take 3 plus 1, 4, and I would change this to 4. So you have using these particular nodes only, you have to check whether I can access that thing. So this ticked nodes, whether I can access that. All possible ways using these three nodes you have to check, and you have to take the least distance. Whereas in the shortest distance also we were doing the same thing only. Visited nodes we used to take the same thing only. Here it is little change with the iterations, and here it is with the visited. So now for f, so using a b d, can I access f? No possible way, so it will be infinity. Can I access g using these three? No, so it will be infinity again. Next, now in the remaining, which one I should choose? I should choose 6. So I'll write down all the 6. I'll take e here and e here also. Now using these 4, you have to check for the remaining. So using these 4, how can I access c? There is only one possible way, that is 7 itself. It will remain the same. Next, using these 4, how to access f? One way is this. So this is one possible way to access f using these ticked vertices. Another way is like this. So let me check which one is less. 4 plus 2, 6, 6 plus 2, 8. So like this it will be 8, and if I'm taking this root, 5, 6, 7, 8, 9, 10. So like this it will be 9, like this it will be 8. So which one should I be choosing? So this one. So it will be 8. And using these 4, can I go to g? No, so it will be infinity. Now in the remaining, which one should I choose? C. So tick the C here as well as here, and now write down all the C's. So now using these 5, you have to check for these 2. So using these 5, how to access f? So there is one possible way is like this, like this, like this. So these 2 I already checked. Like this I'm getting 12, like this I'm getting 8. So I took 8. Now again like this, let us check how much it is. 5, 6, 7, 8, 9, 10, 11. It is going to be 11. So no need. So best option is 8 itself. Now how to go to G? To go to G, one way is I can go like this. Another way is I can go like this. Like this and all I can't go because F is not yet ticked. So using only the ticked, I can go like this. So 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It is a very big number. But if you go like this, 5, 6, 7, 8, 9, 10. If I go like this, it is 10. This is one way. This is one way to go. 5, 6, 7, 8, 9, 10. So it is anyway exceeding. So best way is this only. 5, 6, 7, 8, 9, 10. So among these two, which one I should be taking? 8. So now I'm going to take F here and write down all the 8s, fill in the 8s for the F. So using these ticked vertices, best possible way to reach G. So I can go like this, I can go like this, I can go like this, like this, like this, I can go like this, like this. So let me check. So if I go like this, it is going to be 10. If I go like this, 5, 6, 7, 8, 9, 10, 11. So no need this, and this is 10. Keep it 10. Like this, 4, 5, 6, 7, 8, 9. So if I go like this, it will be 9. So keep 9. Another way is like this, 5, 6, 7, 8, 9, 10, 11, 12. So if you go like this, it will be 12. So best way is 9. So I'll take 9. Now everything is done. G also is done. So they have asked A to all possible. So from A to all possible, B is equals to 2, C is equals to 7, D is equals to 3, E is equals to 6, F is equals to 8, and G is equals to 9. To all possible, A to all the possible vertices. And for this the graph will be, so from A to B, which one I'm, it is 2, so I'm using only this, so A to B. For C it is 7, which means I'm using 5 plus 2, 7, so here it will be like this. For D it is 3, so I've used this particular thing. For E it is 6, which means I've used which one, 4 plus 2, this one I've used, not this. So 4 plus 2 means from A to B to E. For F it is 8, so I've used 4 plus 2 plus 2, 8, so this one I've used, so I'll write it down for F. Next for G it is 9, so 4 plus 9 will be like this. If they are particularly asking for G, from A to G, then you can write this particular thing. Only for E you can write this. If they are asking only for D, then you can write this. Only for C, write this. Only for F, write this. So it is like that. Thank you.